Hi everyone. In this session, we are going to learn one of the most important data structure in programming, that is linked list. So in this session, we will understand what a linked list is, why we use it, and we also discuss some simple real world examples, all in a clear beginner friendly manner. So first, what is a linked list? So linked list is a linear data structure, but unlike arrays, the elements are not stored in continuous memory. Instead, each element is called a node. Each element is called a node, and every node stores two things. One is the data, and second one is link or pointer to the next node. In C language, we explicitly use pointers to connect nodes in a linked list. We manually create pointer variables and assign memory addresses. But in Python, even though we don't write pointer symbols, in C language pointer symbol is a star symbol. But in Python, we don't write pointer symbols. The same thing happens internally. The same thing happens internally. Each node you create from the node class, from the node class, from the node class is a separate object in the memory. That is very, very important. Separate object in the memory. So, and Python automatically gives you a reference to that object. So, these references behave just like pointers. These references just like behave pointers. So, they connect one node to the next node connected to the another next node, like that. But Python handles the pointer management behind the scenes, making it safer and easier for us. The chain of nodes forms called it as the linked list. So linked lists are very flexible. They can grow or shrink at any time. Here, inserting or deleting the elements is much easier compared to the arrays. Okay, because we only adjust the links. We will not shift the data. That is very important in this concept. As I told you, every node stores two things. So first, this one is data, and this one is address of the next node. I am going to use this name is next, or your wish, link, or reference. Okay, but I am using next for the convenience. Okay, so every node have two fields. One is data, another one is, so one is data, another one is next. This is node. Suppose this one node is n1, this node is n2, this node is n3, this node is n4. Here one more important parameter is always the first node refer to head in the linked list. The last node is sometimes we may use the tail, okay, but not in this list. Next, coming to the types of linked lists. Coming to the types of linked lists. Types of linked lists. First one is single linked list. Single linked list. Second one is double linked list, and third one is circular linked list. These are the three types of linked lists. We will discuss one by one with Python implementation. Okay, and next we will discuss what are the applications of the linked list. In real life, linked lists are used in many places, but in this session, I am going to discuss only three main real-time applications. These one is browser navigation, second one is the music player or slash image viewer, third one is the memory management in operating systems. These three are very easy to remember. Okay, now let me explain each one clearly. The first one is the browser navigation. Browser navigation. You have already an idea about the browser in this backward button and forward button. So when you browse the internet, you click back button to return to the previous web page. After that, you click forward button to go to the next web page again. To support this movement, both backward and forward, browsers internally use a double linked list. Double linked list. You have already an idea about the single linked list. A node have one is data field, another one is the address field. But in coming to the double linked list, three fields. This one is data, this one is the address of the next node, this one is the address of the next node, and this one is the address of the previous node. This field is called previous. Okay, so each web page, if you visit, becomes a node in the linked list. Each node contains the current page, a link to the previous page, a link to the next page. When you click the back button, the browser moves to the previous node. When you click the forward button, it moves the next node. Why linked list? Means easy movement in both directions. No need to reconstruct the page history. So very efficient for dynamic browsing. So this browser backward and forward buttons is a perfect real-time example of a double linked list. We will discuss in coming sessions how the double linked list is formed and how it is implemented in Python. So next one is the music player. You are already aware of this music player and image viewer. When you listen to songs or view the photos, you often use the next previous, next or previous. So a playlist or a photo gallery can grow or shrink, add or delete the items. For this dynamic behavior, applications use double or circular linked list. This is loop. Circular linked list also this one is node, this one is data and next, this one is data and next, this one is data and next. Okay, so this address is stored here, one link is formed, this address is stored in this here, one link is formed in this, the address of the first node, the address of the first node is stored, so that the all the nodes are connected in a circular fashion. So that is third type of the circular linked list. We will use this loop symbol. The last song have the address of the first song. That is the main application of this circular linked list. Okay, each song or photo is stored in a node. Generally a photo is stored in a one node. Okay, each node connects to the next item. Next item is also photo or a song, whatever it is, and also the previous item. Previous item is a song or a photo, whatever it is. Here the data has the address of the web page or the song address or a YouTube video address, whatever it is. So moving to the next previous item becomes very simple. Okay, so why linked list means adding or removing songs is easy, no shifting required, smooth navigation in both directions, perfect support for the repeated mode using the circular linked list, this one. So next previous in music players is directly supported by the linked list navigation. Okay, so next example is memory management in operating system. Next example is memory management in operating system, generally free list, free list. Okay, so in this operating system must constantly allocate and free memory for programs. So free memory blocks are stored in a structure called a free list. As I told you, free list, which is a linked list. How it works means each free memory block is a node. When memory is needed, OS takes a block from the free list. When memory is released, OS adds it back to the free list. So here again, why linked list means memory blocks are not always continuous. Linked list can easily connect scattered blocks. No resizing is needed. The list grows and shrinks automatically. So very efficient for the dynamic memory usage. Dynamic memory usage. So OS manages available memory using a linked list called the free list. So now we are going to discuss single linked list. Single linked list. Okay.